Okay, let's give you guys some more practice. So integrate this from e to infinity. So this blue line here is x equals e. So integrate it from e all the way to infinity. So from e to infinity. So press pause and have a go. Okay, so to do this, let's just try and let's just try and integrate this. Forget the bounds for the time being. Let's just try and integrate this. Let's just try and integrate this. So to integrate this, make this substitution. Let u be natural log of x. Then differentiate both sides. We've done this before, so you should know this by now. So that will then give you, so dx equals this thing here. We would then put this into the dx and put the u into here. That will then give us this. These two will cancel out, giving you this. And then now integrate that. That will then give you the absolute value of u. But the thing is, because we're always in the positive realm from e to infinity, we can forget about the absolute value. Just leave it as this, nice and simple. So now earlier we said let u equals natural log of x. So we can put this into the u. That will then give us this. So when you integrate this, when you integrate this, it will give you this thing here. So hang on, let's start again. So when you integrate this, it will give you this. And if you think about it, if I were to give you this natural log of bubble here, so don't forget this is natural log x in here. So if I were to give you natural log of bubble and then ask you to differentiate it, don't forget what's in here is natural log of x. So it would be 1 over the bubble times the derivative of the bubble itself. The derivative of the bubble itself is 1 over x. So what's in the bubble here is 1 over, well, the point here is that, see this 1 over x here, that's this 1 over x here. See this 1 over natural log, this 1 over natural log. So top times top, bottom times bottom. So, well, if you integrate this, it will give you this thing. And then if you differentiate this, it will give you this thing here. Okay, so let's try and integrate this now. So from e to infinity. So from e to infinity, we would integrate it from e to an arbitrary point. Let's say a here. So integrate it from e to a, and then later on we will let a head towards infinity. So integrate it from e to a first. So when you integrate this, it will give you this thing here from e to a. So now, hang on. So now put this into here. So that will be natural log of a, and then you've got natural log out here, natural log here, and then take away, and then put this into here. So that's this bit, and then you've got your natural log here. Natural log of e is 1, and then you've got this natural log of 1 here. Natural log of 1. Remember, the natural log graph looks like this. Natural log of 1 is 0. So this whole thing here will be 0. So from here, that will then take us to here. So when you try and integrate from e to a of this thing here, it will give you this thing here. But now we let so when you integrate from e to an arbitrary point a, it will give you this thing here. But now allow a to head towards infinity. So let a head towards positive infinity, meaning take the limit as a tends to infinity. So hang on. So when you try and integrate from e to a, it will give you this thing here. So now let a head towards infinity, meaning take the limit of this. So take the limit of this. So take the limit of this thing here. Well, the minute you allow a to tend towards infinity, you are really integrating from e to infinity. So up here, hang on. So up here, when you integrate from e to a, it will give you this thing here. But then if you allow a to head towards infinity, then you are no longer integrating from e to a, but you're integrating from e to infinity. So the minute you allow a to head towards infinity, you're really integrating from e to infinity. So now take the limit of this. Evaluate the limit of this. Well, if you look at this here, natural log of a, if you look at the graph, natural log of x, and then as a tends to infinity, what's in here is heading towards infinity. Well, if what's in here is heading towards infinity, then when you have a natural log of that thing heading towards infinity, then the whole thing itself will head towards infinity. So when you try and evaluate this, the area will be infinity, meaning that the integral of this, it will diverge. Okay, so it doesn't converge, it diverges. Okay.